Good morning and happy Friday. Welcome to our last Playdate of the semester. That's hard to believe. It always is. The academic semesters always go by really quickly. My name is Phyllis Newbill. I am an associate director in one of several centers within ICAT. A couple of housekeeping things before we get started. This morning, as always, we are live streaming on the internet, and this presentation will exist on the internet afterwards, and I feel like you all should know that. There are pastries and coffee available. Please enjoy those. We are able to provide those each week because we have a sign-in sheet. So the sign-in sheet will come around, so please let us know you're here. If you are faculty, and Virginia Tech faculty and Professional Development Network credit is helpful to you, PDN credit. Make sure you first sign up for that. There's a QR code on the bottom of the clipboard. And also just check in with me and I will give you your 100% for being here. When you have questions, we'll have some time for questions at the end. When you have those questions, wait for me to get to you with the microphone. If you're watching online this morning, good morning. We're glad you're here as well. Use that questions link and we will be watching those to ask your questions as well. In terms of announcements, I think you all are going to talk about, are you talking about what else is still happening today? Yeah, make sure you include that. Okay, all right. So Dark Matter has some more stuff happening today, and also on Monday is ICAT Day, so May the 4th, be with you, of course. From 3 to 5, we'll be over at the Center for the Arts, sharing our student seed grants and our mini seed grants, so you can see kind of what's coming up in the fun of ICAT. So that, we actually really have a fantastic bunch of exhibits, including last week's presentation from Bambuza. That work will be in the Cube. Dark Matter will be there. I think y'all are there, right, at ICAT Day? Yes, yeah, Dark Matter's, sorry. We'll be in the Perform studio. Right, there you go. They'll be in Perform, and then there are waffle makers and soundscapes and many other things. So I hope you'll be there from 3 to 5 on Monday. We'll also be opening the Open at the Source gallery exhibit. So there's food. Come on over. It'll be great. All right, with that, I'm going to turn it over to Ian Shoemaker from Physics and Dustin Dennis, and I want you to, let's see what we got.
All right, sounds good. Thanks a lot. Thanks so much for coming this morning, everyone. So I'm going to tell you about our joint project, Dark Matter Embodied, a visual encounter into unseen stuff in the universe. So I'm going to talk about the science side of things. Dustin will talk about the design and experience. And I want to summarize at the very beginning everything that's known about dark matter, which is very, very little. So the basic idea of dark matter is summarized just in the name. So it's dark in the sense that it's invisible. So we mean it doesn't interact with light at all. And not with X-rays, not with radio waves, not with anything like that. So it's totally invisible. And it's matter in the sense that it responds to gravity. And that's sort of the crucial way that we figured out it exists. And then on top of that, there's 5 times more of it than there is of all the atoms. So everything on the periodic table, as far as we can tell, is vastly outnumbered by dark matter. And that's really everything that's definitively known. There are many, many unknowns about dark matter. So just to mention 2, one that's crucial for improving our understanding about dark matter is whether or not it has any interactions with ordinary matter. So there are many experiments around the world searching for this effect, but right now that's really an unknown. We don't know if it does interact at all with ordinary matter, besides through gravity. And then very exciting for a particle physicist, which is what I do, is that we don't know if this is one new particle or hundreds of new particles with their own interactions. You know, we may have a whole other periodic table to discover. So the main question that I want to start with and that our experience hopefully is able to communicate is, how do we know this invisible stuff exists if you can't see it at all? So one of the crucial bits of physics that was used to determine the existence of this dark matter stuff is the fact that gravity tugs on light. And so this was first observed more than 100 years ago in 1919, and this was a prediction from Einstein's theory of gravity. The idea is that light passing through a massive object, or passing near a massive object, like the sun, will have its path be bent in the presence of that strong gravity. And that's a basic effect that is underlying what's called gravitational lensing, which is a tool that's used every day now for astrophysics to determine where mass is in the universe. So if you see light, if you know where a star should be, and it appears in a different place than where it should be, you can infer that it passed through some very massive thing. Oftentimes you can see the massive thing, like the sun, but for dark matter, that's not the case. So the main system that our dark matter project centers on, that tries to explain why we know dark matter exists, is this system called the bullet cluster. So this is just what the system looks like in visible light. So this was a picture taken with the Hubble Space Telescope, and all of these splotches of light are galaxies. So there are actually two clusters of them, one on the left and one on the right. And what we believed happened is that these two clusters collided with each other. That's not apparent from this image, but you don't have to just look at it in optical light. You can also look at the same system using X-rays. So this is using a space-based telescope called the Chandra X-ray telescope. And what you see, which is shown in red, which is just a way to visualize it, our eyes can't see X-ray light, but it turns out that this hot X-ray gas in the center is most of the atomic matter in that system. So most of the mass, in terms of ordinary atoms, is in that hot red stuff and not in the individual galaxies. And this is why we believe that there was a collision between these two clusters, and when they collided, the hot X-ray gas interacted and made this interesting bow shock shape, and that's what gives this cluster its name, the bullet cluster. And so if there was no such thing as dark matter in the system, we could use gravitational lensing, figure out where gravity is strongest, and the prediction is that where gravity is strongest should be where that pink stuff is. And it turns out, when you do that analysis and figure out where is gravity strongest, it's in the blue. It's somewhere spatially separated from where most of the ordinary matter is. So it's a truly sort of smoking gun for the existence of some new stuff, something that's dark, doesn't interact with light, but that makes gravity. And so this is now a very beautiful rendition of what we think happened in this collision that Dustin produced. So in this visualization, originally there were two clusters separated, and they each had their own galaxies, their own lump of dark matter, and their own lump of hydrogen gas, and they fell into each other's mutual gravitational attraction. And what happened was that the hot X-ray gas did all kinds of complicated stuff. It's a plasma. It made this complicated bow shock shape. But the dark matter, the blue, didn't do very much. It passed through the other lump of dark matter. It passed through the hydrogen gas and spatially pulled away this new stuff, the dark matter, and the atomic matter, and they occupied different locations. And this is really not something you can explain in the absence of this invisible gravitating stuff we call dark matter. So that's the summary of the science side of things. I'll turn it over to Dustin to talk about the design. Oh, sorry. I was going to briefly talk about also just a little bit to connect to my own side of research with dark matter. So we don't know what dark matter is, right? It's something inert. But there are many different theories about what dark matter is that may allow us to probe it on Earth, either through the heat or energy that it can deposit when it scatters on ordinary matter in some experiment on Earth. And in some cases, we might be able to produce dark matter in the laboratory. And there are many experiments around the world looking for both of these, looking into both of these possibilities. And it's a very interdisciplinary field, and it's been very fun to collaborate with Dustin on this project. So with that, let me turn it over to Dustin.
Hello, everybody. Okay, so I'm going to start by screening a brief excerpt from the beginning of our VR program, just so you can understand what it feels like to be in the VR headset. So Ian is going to hear his own voice. You all are going to hear Ian's voice, so here we go.
Over the years, clear evidence has accumulated that our universe consists of more than just ordinary atoms. All data now point to the existence of a non-luminous, or simply dark type of matter pervading the cosmos that doesn't interact with light. How do we even know it's there if we can't directly see this invisible stuff? While there are a number of astrophysical and cosmological pieces of data pointing to the existence of this dark matter, we'll focus on just one, the collision of two merging galaxy clusters referred to as the bullet cluster.
Okay. So as Ian was walking us through the science of dark matter, what I found myself thinking about was something slightly different. So what would it take to actually experience this? I was responsible for creating the visuals and the audio for the VR program. And my role was really about translation, trying to take this somewhat difficult subject and then make compelling images and sound along with it. Okay. So Ian and I started talking through about how to translate the bullet cluster into something layered and spatial. What we're really dealing with are three different systems, like Ian was mentioning earlier. We're dealing with the galaxies, the hot hydrogen gas, and then also the dark matter component. And each of these behave differently during collision. So the question became, how do we separate those systems visually? While still keeping them connected in a way that makes sense in 3D space. We also had a constraint. We wanted our program to be under 10 minutes. So it meant that every motion that I was creating, every effect had to be really intentional and coincide with the pacing of the program. So I started building the core visual system in Autodesk Maya, using spherical volumes to represent the hot hydrogen gas in the dark matter distributions. Then I brought those into Unreal Engine 5 to begin shaping the overall look. So the red transparent volumes represent the hot hydrogen gas, the blue represents regions where the gravity is the strongest. But what I was really thinking about here wasn't just the color, but it was also the behavior. The gas needed to feel like it collides and drags, while the dark matter needed to feel like it just passes right through. So it's that difference, that separation, what helps communicate the formation of the bullet cluster. Okay. As an artist working with digital technologies, a big part of my practice is trying to develop new kinds of workflows and experimenting with new tools. So for this project, I started incorporating AI into different parts of my pipeline. So not as a replacement, but as a way to push the process forward. So I used Meshy AI to generate some of the 3D assets, things like supporting visual elements. So here we're seeing a diagram of the gravitational lensing within the VR system. And these helped build out our environment, adding context to the main simulation without distracting from it. Okay. Sound became another important layer. I used 11 labs to generate an atmospheric score. We layered this underneath Ian's narration and mapped it spatially in the ICAT Perform Studio. And we're going to listen to this in just a moment. I have a small sample. As you move through the space, the sound shifts around you, and it helps reinforce the sense that you're inside of a system and not just observing it. And it also sets the mood. And for this, I would really like to thank the ICAT staff, Tanner Upthegrove and Brandon Hale, for their help in assisting me in setting up the spatial audio for the experience. So we're going to listen to this for just a few moments. I also worked with an AI agent directly inside of Unreal Engine, using Claude Code to help build and troubleshoot shaders. So here it's helping me adjust things like emissive color, opacity, and surface shaders. So it's assisting me in building some of the blue dark matter color. The AI wasn't perfect, but sometimes I had to troubleshoot what the AI system broke for me. That was always fun. But it was incredibly useful for iteration. It started to feel less like a tool and more like something that I was collaborating with. One of the most technical challenges was building the gravitational lensing effect. This effect simulates gravitational lensing by bending everything that you see in real time within the Unreal scene. So the entire scene behaves as if it's being distorted by gravity. What was notable here is that the real-time effect doesn't just affect the background, it's distorting everything in the scene. So instead of explaining the lensing when you're in the VR system, you feel like you're witnessing the gravitational lensing or experiencing it. Let's see. Oops, I missed one. Okay. Finally, I used Unreal Engine's Niagara system to build the two galaxy clusters themselves. Each cluster contains both the gas and the dark matter system, and this is where the motion comes together. You start to see the separation, the gas interacting, dragging, forming the bullet shape, and then the dark matter continuing forward unaffected. And then, here's a lovely photo of us. For me, this project sits somewhere between science and speculation. We're not simply visualizing dark matter itself, we're visualizing its effects, its behavior, and presence. And in doing that, we're building a bridge between something we can only infer and something that we can experience. And with that, I want to say thank you to ICAT, and also thank you to all of you as well. Yeah. So I think, Phyllis, should we take questions now? Yeah.
Thank you so much, Ian and Dennis. This is, so you all have an ICAT seed grant, correct, for this one? And I'm going to ask a question first, actually. Can you talk about how this project got started? How did this happen?
I'm trying to remember back, actually, Ian, to the specific moment in which we decided to do this. Ian and I have some background. We both have spent time in New Mexico. Ian is from Albuquerque, and I have family in New Mexico. So we're friends, I would say. We hang out from time to time. And so I don't know if it was over a lunch conversation or exactly when we decided to work on a dark matter project, but I thought what Ian was studying was super fascinating, and I wanted to find a way that I could be involved. And I really like the challenge of trying to make something that's invisible visible. So I think that was like a lot of fun. Yeah. Do you have anything that you'd like to add?
What questions do we have? I should have asked that first so y'all could be thinking after.
Phyllis took my usual question, so I'll ask another one. Great project. Really enjoyed the demo when I saw it the other day. Can you say a little bit about the process of working together, developing things, and just a little bit more about how the team functioned over the last several months?
Sure. Do you want to take it? You want me to?
Bolos was important, right?
Bolos and coffee was important. Our process was, we first had a lot of conversations over the phone. I think at one point, I think I was in New Mexico, Ian was here, we were traveling back and forth, and so we were having a lot of conversations and deciding we knew that we wanted to do something with dark matter, and the bullet cluster came up. Our workflow was such that we developed a script first, right? We developed a script together to try and figure out like the main things that we wanted to discuss about the bullet cluster, and I translated that into a visual script that we could use it to begin making animation, and then we started building the VR program. Yeah. Is there anything that you would want to add?
Yeah, I think that's.
Okay.
I've yet to experience the project, but I will this afternoon. But I'm curious maybe what people's reactions afterwards, or if people have asked you any questions about it afterwards, because I think when I think about space, it always seems quite incomprehensible and very like overwhelming, and so I'm curious if people have come out and, I don't know, had questions that have made you think about the project in a new way, or anything like that.
One thing that was surprising is just how people respond to VR. Like the actual physical experience of being inside of the system and using the headset can be a little disorienting. So there was definitely a moment in the beginning when I was prototyping some of the star map scenes where I would put the headset on and become kind of dizzy and like offset. So it's been really fun to watch people put on the headset and then kind of be transported for a few moments. Yeah, Ian recently brought his daughter to experience the VR experience. Do you want to mention anything? How did your daughter respond to it? Did she?
I mean, I think at first she just thought it was funny hearing my voice more than anything. Yeah. No, but she already knows some about dark matter from, just hanging out with me. So, yeah.
How old is your daughter?
She's in 6th grade, yeah.
Okay.
12.
And was she excited about the immersive?
She had some dizziness from the VR. So that's, I think VR is sort of a double-edged sword, right? It's a powerful tool, but right, some people just don't react well to it. Yeah, so that's something, like, we definitely hope that we can build on this project. So we'll have to see, like, what for step 2, if there's another way to sort of have it be immersive, but ideally, not impact some people in a negative way.
When some of the first VR things that we did in the cube, everyone who was working on it was this much taller than me.
Yeah.
And so when I would go into this is early on, but when I would go into the immersive environment, I would not be hitting the floor with my feet. It was the weirdest, but I can't imagine what that is like in deep space. When there's no floor, there's no ceiling. I feel like that could be really, yeah, I will. Don't worry, I'll be there.
Yeah, thanks, guys. My question is, when you're working on this project, who's your audience? Is it scientists? Is it artists? Is it students? Who are you sort of targeting there? And then part 2 to my question is sort of, what would next steps be if you wanted to expand this?
Yeah, I mean, my thinking is that the main audience is a person, ideally, who doesn't know anything about dark matter, because to me, it's very mysterious, right? It's the majority of matter in the universe, and yet we know almost nothing about it. And I think, to me, that communicates a crucial, exciting part about science, which is, there's a lot about the universe we just don't understand, and it's an ongoing process. We have these things like the periodic table, which give us this great sense of order and having figured everything out. But in reality, it's a false sense of security. There's a lot. It's an ongoing process. And I think the more that people know about just dark matter, that it exists and that it's mysterious, hopefully this experience sort of functions as a gateway drug to just, being excited and interested about dark matter and science more generally, and continuing to fund this type of fundamental research, which is ultimately driven by curiosity, you know? It may have technological impact, but that's not why I'm interested in it. I'm just interested in it from a pure, let's figure out the universe standpoint. And in terms of like building on it for the future, that's another component that I think would be great to naturally build on, is that this project was mostly focusing on why do we know dark matter exists? And then I think the future would be nice to connect with what sorts of experiments in the near future are going on right now that will further our understanding. Yeah.
I did get to see the experience and I really enjoyed it. So if there's a way to plug how other people can sign up next week if they want to see it, maybe do that. But also I felt like you all struck a nice duration and complexity level for it because I don't know much about dark matter. So were there considerations in that regard, or like how would you advise other people on maintaining audience engagement and like how deep you get with the science?
Yeah, I think you know, largely just from us talking back and forth and figuring out, you know, what is it that people know and are able to digest about dark matter in this relatively short experience. I think that was sort of like the first order considerations. Yeah, and again, just thinking of it as a stepping stone, you know, that hopefully gives some sense of like what would be a good thing to build on for the future. Yeah, do you have other?
I mean, in our early conversations, it's one of the reasons that we wanted to keep the program short, too, is I think it makes it more approachable. If it were like a 30 or 40-minute VR experience, that would be a kind of a different, detached thing. So I think like keeping the program to like under 10 minutes, at least for this first prototype, was a good like length for the duration. You know.
Hi, since we have time, can you speak a little bit about the slide that you moved through real quick about the research being done? I'm just so curious.
Yeah, sure. So, you know, so a short thing to just keep in mind is, right, so since we don't know anything about dark matter, any one of these experimental avenues may not work out, but it's exciting that there are many different complementary directions that are being pursued. So a simple possibility is that, you know, maybe, you know, we know that dark matter is in the Milky Way, and so if it has some interactions with atoms beyond gravity, then it should be possible that this dark matter that's flowing through the room, you know, flowing through the Earth all the time, will occasionally scatter. And if we have a very sensitive experiment set up where we really understand what's going on, if there's some extra heat or extra energy that just appears, that should be a telltale sign, you know, that telltale sign that there was some dark matter that scattered and deposited energy in an experiment. Those are called direct detection experiments. That's something depicted on the left. And typically these are buried underground to shield outside sources of noise and so on. And there are dozens of those experiments going on around the world using all kinds of different technologies. And so, you know, that's a very interesting direction. Another possibility that's even more speculative, but definitely possible in certain theories of dark matter, is that we may be able to produce dark matter in the laboratory directly in high-energy particle colliders and accelerators, and then see it in one of two ways. You could see it because, you know, you produce it and then it leaves the detector, so it steals energy from the detector. And in some cases, you know, you may be able to produce it and then see it rescatter some distance away. So there are other directions too, but these are some of the most interesting ones. Yeah.
Thank you. We are at time, so I'm going to actually close with we need to talk, because like there's a science museum and a science festival that I need to talk to you about. Okay. All right. Thank you so much for being here this morning. Thank you all for sharing your work. Again, this is our last Playdate of the semester, so we'll be back in the fall with more pastries and donuts, and every Friday morning, more great ideas. So I hope you'll be there for that. Meanwhile, have a fabulous weekend and a fabulous summer. Thank you all. Yeah. Oh, wait, one more thing. Oh.
And one more thing, you all. There is a sign-up sheet on the ICAT webpage to experience the VR program. So please go over to the ICAT page for Dark Matter Embodied, and then sign up. There are spots for that. And thank you all. Thanks.
Perfect. Thank you.